So welcome everybody to this panel session. Let me first briefly introduce the panelists. And two of the panelists you've already sort of met in the presentations of yesterday. And that is Professor Larsen from New York, and also Professor Lee Ching Ng from Singapore. And the one that you have not met yesterday is Assistant Professor Janelle Thompson from Nanyang Technological University, also in Singapore. And let me briefly say something about her background. She is an environmental microbiologist at the Asian School of the Environment at the Nanyang Technological University and a principal investigator at the Singapore Center of Environmental Life Science Engineering, SCELSI. And maybe, Janelle, maybe it's good that you, the others panelists had the opportunity to share their experiences in a presentation. I'm not asking you to give a presentation, but maybe you could, before we kick off with the questions of the people in the audience, that you could share briefly your experiences in this sewage surveillance.
Sure. Thanks very much for the intro and for giving me a couple of minutes to introduce my team. Good evening, everyone. So I'm Janelle Thompson, and I'm an associate professor at NTU in the Asian School of the Environment, and also a principal investigator at SCELSI, the Singapore Center for Environmental Life Sciences Engineering. And I've helped lead a collaborative working group on wastewater surveillance for SARS-CoV-2 since right about after Lunar New Year last year. And about a year prior to that, in 2019, I had teamed up with my colleague from MIT, Eric Alm, to submit a joint proposal here in Singapore to the CREATE Directorate. And this is part of the National Research Foundation of Singapore. And our proposal was on sewage surveillance for outbreak detection and response in Singapore. So this project is now funded, and it's focused on integrating surveillance of dengue virus and other human RNA pathogenic viruses into the wastewater surveillance network in Singapore. And of course, this surveillance network has expanded dramatically in the past year. So we've got diverse co-PIs on the project, including Karina Jin, who spoke yesterday and also was on the previous panel, as well as colleagues from public health, social sciences, and health technology assessment. So when COVID-19 cases began emerging in China and Singapore, right before Lunar New Year last year, our team connected with PUB and NEA, so two of the agencies dealing with water and public health here in Singapore. And then we interacted extensively with NEA during those first few months, and we helped them work out the protocols for testing wastewater, and that work was done at labs at NEA, and also to some extent at SCELSI and the CREATE campus, where the Singapore MIT program is based, as well as E2S2, which Karina belongs to. Initially, all the work that we did with wastewater with detectable SARS-CoV-2 was done in NEA's BSL-3 labs. And since, in those early days, we didn't have the confidence that it was safe to work at BSL-2 or BSL-2+. And so that's where we tested out things like tangential flow filtration and the PEG concentration. And, when we were able to add in Amicon columns to the workflow, it was a real time saver. So we also, during that time, worked with NEA to set up the monitoring framework with PUB that included waste treatment plants and community manholes. Now, our team kind of got tied up with legal issues on our administrative agreements. So unfortunately, we weren't really able to support any of the sample analysis of Singapore wastewater until fall this past year. But that work has continued through NEA and PUB and NURI teams. So we were able to make several contributions that hopefully are meaningful and useful over the past year. So first, we provided scientific input to the development of the monitoring programs that were led by NEA. And I just want to highlight that wastewater testing for SARS-CoV-2 is such a young science. It's really, brand new, as old as the pandemic. And we really don't know how reliable our estimates of shedding rates are, for example. And so I just think it's really remarkable how NEA in Singapore were able to take this young science that had so much uncertainty and then implement it in a way that actually added value to the management of the really serious outbreak in the worker dorms. Coordinating it with clinical testing. And that could allow you to find the asymptomatic carriers and to confirm if a dorm, or help confirm if a dorm is clear from the disease. So that was a really important opportunity for us to participate in sort of the thinking through that. And I appreciate having had that chance. Now, our team also collaborated closely with our colleagues at MIT, who are based in Boston and in Singapore. And we issued one of the first reports that SARS-CoV-2 RNA was detected in wastewater back in early April. And that work was based on samples that came through the Boston wastewater plant. And the work was based out of my collaborator's lab, Eric Alm at MIT, and Biobot Analytics, which is a spin-out company. And so we also did a follow-up study that kind of demonstrated that 1 week lag phase then between the observations of trends in wastewater and trends in clinical cases. Now, earlier this summer, my team at CELSI was tapped to manage the implementation of the campus wastewater monitoring network for our halls on NTU's campus. And so that's proceeding in parallel with NUS. It's based on the protocols that are established by NEA and MOE. And just one final point. So lastly, we put together a prospectus manuscript on using wastewater surveillance for public health management. And this was a collaboration across an international set of colleagues, and it included a social scientist from NTU, Professor Monami Haynes. And we really spent a significant amount of time thinking through the ethical issues of wastewater-based surveillance. And this could potentially intersect with the topic of this panel when we talk about reporting. So a few highlights, for example, we suggested that wastewater monitoring networks be designed to sample at scales that give a reasonable level of anonymity and avoids collecting household level data, because we felt for household level data, you can obtain consent for doing individual testing and pooling samples. We also kind of recognize—
Sorry to interrupt, but did you set a number on the size of the population? Sort of what is the minimum size?
We didn't go through that analysis, and I think that's an important thing to put our heads together and do. I guess, yeah. It really also depends on what targets are going to be analyzed when you do that as well. Like if you can, at what level you lose any sort of human DNA signal for back calculating. And if you're not actually going to do that, if you're not actually going to measure any human DNA signal, then I think you can have a finer scale of resolution in that case. But I think that's a great question, and one that certainly warrants kind of a more detailed analysis. So we were also thinking through the issues of social inequalities, where policymakers should be mindful to not introduce sampling biases in their placement of sampling points for general surveillance of communities. And then when targeted surveillance is warranted, such as in the worker dormitories, we felt it was really important that those programs be disclosed and communicated, and then coordinated with the availability of interventions. And so we also highlighted then that the success of surveillance programs requires public legitimacy and trust. And if that broke down, you could witness creative forms of public resistance. And it's really notable that in some communities, in some countries, wastewater surveillance is used for law enforcement. And so if the goal of wastewater surveillance is to manage public health for infectious diseases, then communication regarding these goals is really important. And providing oversight for the wastewater surveillance program should include diverse representatives of the public interest to really maintain that public legitimacy and trust in the program. So that's really all I wanted to say to kind of introduce myself and the interests of my team. And thanks a lot for the chance to do that intro, and I can turn the floor back over to you, Gurchan.
Okay, super. Thank you, Janelle, for the introduction and also the insights that you've learned in your collaborative research and you could share already. And I think, well, one of the things that you said is sort of a link to the question, or one of the questions that was posed, and it may not be so much about the topic of our panel, so data analysis and reporting, but it is something that has been since the beginning of the pandemic also been floating around this idea, or the concept of sewage surveillance, and that is infectivity of the SARS-CoV-2 in the environment, and we find the RNA of SARS-CoV-2 and in the environment in high concentrations and in many places, and we can find it even after wastewater treatment in some instances. So people in the wastewater community, but also in the larger public, have been asking the question whether we think we should be worried about that. And traditionally, we think about water as and waterborne pathogens as where water is a transmission route. But I think at least my thinking is different in this situation. But I'd like to also ask the panelists about their knowledge on this particular topic. Should we be worried about SARS-CoV-2 transmission through the wastewater? Maybe Professor David Larsen, can I put you on the spot?
You can. I'm not a microbiologist, and so I come at this problem differently. You know, from an epidemiology's perspective, we typically see mathematical and statistical abnormalities for populations of greater risk before we understand the biological mechanisms. And so this occurred with Zika and microcephaly, where abnormalities in the number of microcephaly was occurring before we understood what Zika was doing. And so I would look to this to find, well, what's the COVID-19 incidence rate among wastewater treatment plant operators? Is it higher than would be expected? And I have not seen that. And so that's the limit of my expertise. I can't speak to the biology of the virus in wastewater, but from an epidemiology standpoint, it does not appear to be an increased risk for wastewater treatment plant operators.
Yeah, I understand, and I think there is indeed multiple ways to look at it, and but one of the ways is the one that you are referring to, and that without epidemiological indications in any of the countries that we've looked, and several studies that have been looking at work-related exposures, and maybe we could even go to hospital workers and fecal exposure from patients, and also there the increased risk of this population and this type of exposure seems to be well insignificant in relation to all other routes of exposure. Professor Li-Ching, are you?
Hi.
Will you also share some insights here?
Well, for us, as we work, we treat it as infectious, mainly because number one is that the wastewater does not only contain stool, which is pretty unknown. As I mentioned in my talk, they contain sputums, respiratory fluid, from bodily fluid from the patients as well, who spit into the sink. And we do, I think there are also literature showing, we do find them. And literature also shows that one of the highest rate of detection is actually in the basin, in the U-tube, the U-pipe under the basin where people spit and brush their teeth, whatever. So we treat it as infectious, and also considering some of the evidences that have come out from China and Taiwan. 2003, there was a SARS outbreak in a building, and it was speculated, or they think it's due to the sewer system in Taiwan. in 2003.
Hong Kong,
And
yeah.
was it Hong Kong, not Taiwan?
Yes.
Sorry, Hong Kong. And more recently, the Chinese paper talking about how the sewer sort of leak onto the road, and people walking by and bringing them home, and leading to another cluster in a nearby apartment block. So with all these evidences, despite I think only a few labs have perhaps managed to isolate the virus, we are taking all the precautions that we need. So for us in the field is a PPE with an N95 mask. Our PPE is just a jumpsuit. It's not because we are in a community, so we are not in this full gear. In the laboratory, we work in BSL2 plus facility. So under restricted control access, work in class 2 hood, class 2 biosafety cabinets, and all the measures that applies to a BSL2 plus, higher than 2. So there's no answer, so we take precautions. Yeah.
Yes, and I think many of the precautions you would also need to take for all the other viruses and parasites and bacteria that are present in wastewater.
Yeah,
so
that's right.
Yes, wastewater is an infectious material. So you need to take precautions when you work with or even in sewers, or you do cleaning, or you work in a lab, or you take samples. You need to take the necessary precautions.
And that includes some of the vaccination. That includes some of the vaccination that has to come
that's
together
indeed true.
with.
Yeah. Yeah, so I've seen several studies that have looked into trying to detect if there was infectious virus if infectious SARS-CoV-2 present in wastewater, so to see if they could use cell culture to find infectious virus. And what I've seen was that they were negative even in the presence of relatively high concentrations of SARS-CoV-2 RNA in the water. And I've also looked at their upstream that also already in stool samples, it's quite difficult to isolate infectious SARS-CoV-2. But I think Professor Ng, you were also alluding to that stool is not the only route by which the virus can enter the wastewater. So also shedding via other routes from mouth washing, nose rinsing, spitting, it is something that can produce high concentrations of virus that enter the wastewater. Okay, maybe we move to other questions that are related to the topic. I think that there was a question that is still open from day one for Professor David Larsen. And that was about the variability in the crash phage measurements. And if you can speak to the topic of crash versus pepper-mild motavirus, and how you can use that to understand the human fecal load and estimate or normalize SARS-CoV-2 concentrations.
Yeah, so the variability I can speak to with good expertise, and it doesn't vary that much, especially within sewer shed. When we ran correlations with the flow times the population and the crash phage numbers, we were getting correlations of about 0.9. And then it's very consistent. We're working on looking at longitudinally how temperature and precipitation affect the crash phage detection over time here in upstate New York. In terms of why we chose crash phage, I think I was talking with Hyatt Green. He's my microbiologist colleague, and he makes these decisions. And he was saying that the pepper modeled the pepper virus, I always have a hard time saying it. It lasts a little bit longer in the wastewater than crash phage does. It's more durable, and so we expected early that the crash phage would be more similar to the way that SARS-2 would act. and that was an assumption and a hypothesis that needs to be tested. I don't think anybody that I've seen, I haven't seen anything comparing the two different surrogates in terms of their ability. And so that's what we did, and I think in the end, I think either is probably okay. That either one would probably work okay, and then, you know, if anybody wants a good topic to test, would be the difference in different denominators that could be used for estimating intensities and things.
Thank you. Yes, and I can share the same experience. We are using Crashphage as well, and in the different sites. And if you compare flow normalization with Crashphage normalization, as you say, the correlations are really high. It's amazing to see a microbial parameter that is so constantly present and really can tell you about how much dilution you have of the wastewater through rain events, but also in some cases we have one site where there's at a certain moment a lot of groundwater was getting in there. So you see it in the flow and you see it in the Crashphage. It's a nice way to as an extra parameter to confirm your flow normalization and that everything has gone well with your analysis. Okay, then other questions? I'm looking through them. Oh, that's not easy because it's also moving. Yeah, this is a very generic question, and but it is good to have some discussion on that. So, are we ready to use wastewater-based epidemiology as a routine public health surveillance tool? And if not, what else needs to happen? And I think, well, Janelle, that you were indicating that you've already broadened the wastewater surveillance from SARS-CoV-2 to dengue, and I think I heard Professor Liqing Ng say yesterday also she was interested in Zika virus. So maybe and others have been looking and are looking into antimicrobial resistance and illicit drug use. Are we ready for it? And if you think there's more that we need to do, what would it be? Maybe Janelle, you first.
Sure. You know, certainly it's early days for most viral and pathogen targets. Of course, polio surveillance has a long and kind of proven history with the wastewater surveillance field. So I would say, yes, we're ready to start building up our data set of what things look like. And if we compare the relative cost of a wastewater sample to sampling 10,000 people, you know, you can get an aggregate view of what the population is doing through that wastewater sample. Now, how to interpret that in a quantitative fashion, that's science that still needs to be kind of refined. But I think we're ready to start building up our knowledge base for how complex and multiple targets behave in wastewater. Because if anything, our ability to analyze this data set will improve with time.
Yes, I fully agree. And Professor Liqing Ng, did you have anything on this topic to add?
No, in fact, we haven't done anything except COVID at the moment. COVID has started us off on this track. As I mentioned, I have always been interested in doing Zika because we specialize in vector-borne diseases, especially Aedes-borne diseases. So moving forward, I think we have a platform now that we can tap on for many other diseases, which could include, as you mentioned, antimicrobial resistance and enteroviruses and Zika and dengue. I'm not sure, but we'll try. But as it is now, just using for COVID is already a public health tool, public health surveillance tool for us. It is integrated into the national surveillance system. So we can talk about reporting later. So these are all reported on a regular basis to our stakeholders. Yeah.
Yes, but how do you see the future? And maybe the future is already quite close in the coming months or so, when vaccination really kicks in and we regain control over this virus, and the testing streets run empty and the sewers run empty, at least for the virus, for SARS-CoV-2. Will there be what is needed to keep the momentum and keep the incentive? Because there need to be somebody who is asking for and paying for this type of surveillance.
So if you look at a surveillance system, you have the clinical testing, people who are symptomatic that goes to the doctor and get tested. In Singapore, we also have got some regular testing among the frontline workers and at the dormitories as well. They get regularly tested even without symptoms. That forms part of the surveillance, and wastewater is another one. So among all these, certainly something will probably we need to step back after a vaccination program when things settle down. So it's not in the conversation yet, but the question probably will be what needs to step back? And could wastewater become even more important?
Yeah, that I would fully endorse your statements because I think the same. But I also see that, as Janelle was saying, that it's really a young science, and certainly at the magnitude and scale that we're doing this now. So I think. In the water world, we would need to make our case for the value of sewage surveillance, making use of the SARS-CoV-2, the COVID pandemic, to demonstrate the added value of looking in wastewater, and maybe that's
yes,
maybe something good can come out of this pandemic in that sense.
Yes, I think a lot of things have come up, as I mentioned as well, how the agencies work together has been amazing in Singapore. But we also talk about the evasive strain that may evade the vaccine and re-emerging possibility. I think the jury is still out. We still don't know what the outcome of the vaccine would be. So I think it's not. Perhaps, as I mentioned, could then wastewater become even more important to track this kind of up and down following vaccine introduction? So I personally think that it's very valuable despite the vaccine introduction and waning of or the improvement of the situation. So in our case, for example, during the outbreak, we detected positive cases. And okay, you get positive, and the question is what, right? We know there's transmission. And in fact, we continue to ramp up when it's negative. After it turned negative, we continue to ramp up the coverage because we feel that it could be even more important now to pick up any rise in cases. So I think likewise with vaccination, you get reduced cases, but it may become even more important to pick up any surge in future.
Yeah, so I would again agree there, and maybe going on from that point and look at data analysis and reporting. I recognize that Singapore now, and same as in Australia, you are in a different phase of the pandemic than we in Europe and in the US, and I mean, all our sewage samples that we analyze, we find SARS-CoV-2, and if we're looking within a city, we find it in all the samples. Some a bit higher, some a bit lower, but and there we of course there is quality assurance questions, but in the situation where you're in and where Australia, for instance, is in, and other countries, where you have sewers that are negative and you suddenly find a positive, this positive becomes, as you say, even more important, but also the quality assurance around that positive may become more under higher scrutiny than the controls in the setting that we're in. Is that something that has come up in the discussions in Singapore? To when do you call something a true positive and act upon it, or is that the scrutiny of the QA identical to the previous situation?
Yes, it's all under scrutiny. But we report as it is. So as we mentioned just now, yesterday I mentioned about the two genes that we screen with one. If it's positive, we screen with the second gene, and then we do in triplicates and all that. So if it is not consistently positive, we'll call it equivocal, and then we wait for the next sample. Wait, you continue to wait and see. But meanwhile, it depends on the they could activate swab already around the community. But swab has always been ongoing in this community in the workers' dormitories, the routine swab. So they may quicken it, bring it forward because of if it's a positive. So yes, we have a criteria. We call it positive, equivocal, otherwise negative. They're all under scrutiny, and we report it on. If it's positive, you will report it immediately. Yeah. Otherwise, it's a weekly basis that we report the results.
Okay, thank you.
Yeah.
And if I might add to this question of sustained wastewater surveillance, infectious disease surveillance broadly always has this problem that nobody wants to pay for it. And precisely the deliverable of infectious disease surveillance is that nothing happens, that we found the threat, that we neutralized the threat before it affected the lives of everyday people. And so here we have an incredible failure of our public health systems, at least in the United States, an incredible failure of our existing public health systems to understand how widespread transmission was early in the pandemic and to understand how to respond early in the pandemic, when wastewater surveillance would have been the most useful. Because I think once you're in the midst of it, then it does correlate with the cases, but there's also hospitalizations happening and people know that it's happening. And so I consider wastewater surveillance as, to me, it's the most cost-effective way to rapidly and describe the geographic extent of a pathogen. And so with that, I consider it a pillar of our health security and an important part of our health security infrastructure to continue. And for it to work, to be able to be pointed toward a new pandemic or epidemic threat, there needs to be some constant use. And so I would encourage programs to identify what's a pathogen of concern in their community, whether it's dengue or Zika or maybe influenza or something else. Can we monitor that over time? And just to keep the system operating so that it can be pointed to a new threat when one arises, because we know that this is the third coronavirus to jump over in 20 years and affect our well-being. So.
Yes, I totally agree with you, Larson. It is something that we hope to do as well. Post-COVID, even if we don't need for COVID, we will continue to use it for other diseases. As you said, keep the platform going. We have built the platform and we want to keep it going, either for surveillance for diseases or even just research, so that when there's a need, you can just wind it up quickly. Yeah. And I think
Okay.
I just want to comment on what Aaron mentioned just now, that I truly fully agree. Aaron mentioned about when you set up a system and you need to know what's the outcome. What do you want in the end? You know, we often start with a question first, but in fact, in many things that we do for public health, we need the end point. What do we want in the end? And that determines whether we want sensitivity or want how fast you want. And in our case, that's why we call the use case. What use case do we want? And in wastewater, we've got 3 different use cases. Some are very urgent, like the cluster investigation. We use more sensitive tools and we work overnight for it. Whereas the others could be surveillance and it's more regular and more steady state kind of. So the reporting system also differs depending on the endpoint that you want.
Yes, Janelle, you also wanted to chip in there?
Well, from the future-looking perspective, you know, Singapore has coined this phrase "disease X." You know, looking forward to emerging threats. And one area that I would, you know, I'm very interested in continuing is untargeted approaches or more universally targeted approaches. So, you know, once we're all over COVID-19. Would it make sense to monitor coronaviruses and just keep a handle on what's going on with coronaviruses in the sewage, knowing that they're a troublesome group, and we could see an uptick potentially at an early warning for disease X. I mean, whether or not that's feasible, I think our research needs to deal with that. But this is an area that I think is worth considering.
What about
Yes.
influenza?
Yes, also there, I think that we have been looking at influenza during the pandemic of the Mexican flu that was there. I don't recall the exact year, but we also looked in the wastewater and we could detect the influenza in the wastewater. But that was more like a small research effort and did not rise to the substance that this SARS-CoV-2 has. But yeah, it's there's possibilities for even for, let's say, the non-enteric viruses like SARS-CoV-2 and influenza and dengue and Zika, maybe potentially. Okay, there was it's a question from somebody from the audience that listened to Dr. David Larsen's talk about the crash phage and wondered whether the 0.9 correlation was indeed with the crash phage. I think you mentioned that it was, right? So it was a correlation between flow normalization and crash phage normalization.
Yeah, it was. I've never seen a correlation that high in my career. You know, I work with a lot of human data, and a correlation of 0.3 and 0.4 is pretty good. And I was just blown away by that. You know, double, triple checked it because I thought we'd coded it wrong. It was so high. So it works really, really well.
Yeah, same here. I'm in microbiology, and in microbiology and fecal pathogens and indicators, sometimes between 2 indicators you get a good correlation, but nothing of the sort of between crash phage normalization and flow normalization. Yeah. It's intriguing to see that we can use these tools and that they've become available to us now, and have also shown their value in this sewage surveillance system. Let me see, this is a question that is that about report data analysis and reporting? This is, I have to get rid of the chat. I'll just read out a question and then see what we do with it. Some large industries do not mix their industrial wastewater with human waste from their employees, and they segregate, handle, and treat those 2 streams separately. And the question is there any possibility of detection of the SARS-CoV-2 in the segregated industrial wastewater? Maybe I'll kick off any response here, and that is that we, at a certain moment in time, we did this with slaughterhouse waste. And we were, of course, extra cautious to see if there would be any, because this was pigs, and pigs don't normally get this coronavirus. So we were pretty sure that anything that we would find within the animal waste stream would be human derived, and we found some in that wastewater. But the slaughterhouse indicated that they were really separate sewers. So then we were sort of stuck to see was this then still a spillover of human waste into the animal waste stream, or if there's something other going on, because these were also more difficult samples than the domestic wastewater samples we normally have. So if we do industrial waste samples, we have also got requests from the oil refineries, but we've turned those down because we haven't validated our methods in these types of waste streams. So that's what I can say about the lessons we have learned thus far. Are there others that can say something about this?
I can speak of industrial campuses. And so before it's mixed with the industrial waste, similar to what they've done with the dormitories in Singapore, the workers' dormitories, and look for outbreaks there. That's worked, but never done anything with industrial waste.
Yeah. Okay, then a question that just came in. Can the panelists comment on the approach to data analysis from the large pool of results generated? I am not sure about the exact nature of the question. I think data analysis is conducted in each for each individual point where sampling is, if it's a dorm, and then you try to take representative samples of the dorm, and then take action if you find something there. If it's in a city, we already discussed this. Li Jing-Eng was saying there's different use cases for cluster rapid detection of clusters, and then tracing and trying to stop the outbreak. But we can also think about if there's any potential for data analysis at larger scale, and then we come into issues of how well can we combine data from one lab to the next into an overall picture, and maybe that is also something we can comment on. Is there anybody from you that from the panel that want to share their thoughts there?
I can talk about this a little bit. There's a variety of different methods that different teams are using to quantify the RNA out of the wastewater, and then different standardization methods. But what I have seen less of in the literature are detailed understanding of how to use time series analysis with regards to this, and how to use freedom from disease principles in regards to this. And that's where I think some epidemiologists and statisticians can come in to help introduce how we can think about these different data streams. And there's multi-level effects. I've thought about the nested structure of the data. If you have sewer sheds within wastewater treatment plants, and then there's a spatial correlation with the data as well, and so it can get quite complex. And I think that's where the comparison between, say, like the Netherlands national program and Michigan's state level program would be interesting, is to look at similar methods and see how they track the pandemic in the same way and get similar results. on the data analysis side.
Yeah, so then maybe it's less the absolute nature or the absolute value of the data, but more the relative value of the data in their respective data series that become important, rather than well, it is to 20 gene copies per mil in the Netherlands the same as 20 gene copies per mil in Michigan.
Yeah, and so I think that comparison is less useful, because if you have the same method, and we're kind of dealing with this in New York State, where you have the team that I'm on, and we've been in 14 counties. There's New York City's doing their own with 14 wastewater treatment plants. They have a different laboratory and method analysis. And then there's laboratories that are now offering wastewater testing commercially. And so there's different communities have signed up with different labs. And the State Department of Health would like to integrate all of this into a network for better public understanding and decision making. And from a data perspective or epi perspective, as long as the method is consistent across time and is relatively sensitive and has minimal variability, right? Those are the two issues that are going to be present with any method. Then we can actually apply the same data analysis principles to understand pandemic trajectories. And when you have an alert, like an outlier event with a spike or a drop, and then when you have the negative results and trying to build confidence around the negative results. And so from that perspective, it's kind of okay to combine everything, but you have to move away from looking at absolute numbers detected and toward modeled outputs and compare the modeled outputs.
Yes, it's my understanding that also in the US national wastewater surveillance system that CDC is now where CDC is trying to bring everything, but a lot of information under one umbrella, that they also take this approach of not doing the value comparison, but more like the data analysis trend type comparison for the different sites.
And exactly, they are doing that. And the other side of this is that the people who will pay for this, that I see paying for this, are health departments. And health departments are so used to using case data, and cases between cities is going to be dependent on the public health infrastructure within that city, the testing availability. And so even across cities and states, the case data is not very comparable. And so then correlating case data with wastewater and then trying to compare absolute values, it's not the way to go. You have to look at the trajectories and the model outputs.
Okay, thank you. Li-Ching or Janelle, you have thoughts on comparison between?
It's actually quite nice to be small. So in Singapore,
I know. Well, as country, I'm not a small person, but as a country, we're small, and that has advantages.
It's really nice to be small. So we coordinate among the different labs. Now we have 5 labs and all using the same technique, same tests, and we try to standardize it. And we even share protocol, we share standards. So basically rather similar protocols among the 5 labs. But again, when it comes to sort of upstream, it's very difficult to standardize because the wastewater flow is different, community size is different. So that is really positive or negative to detect. So different use case again. Whereas in the wastewater treatment plant, then I think that's when it becomes, the trending is then very important there. To see, and we've seen that in Singapore during the peak of the outbreak. It was positive, and then it came down. It was really nice. Today, most of our cases, we get about 14 cases per day or per week. I can't remember, per day maybe. And they're mostly, almost all of them are imported cases. and they're under quarantine. So we only diagnose them because there's a swab test before they exit from the quarantine, from the hotels that they're quarantined in. So there's hardly any local cases. So it's negative at the moment, but what we're doing now is I'm not a statistician, I don't know much about mathematics, but we're trying to combine the epi data, and we have another group working with us from the university that's combining the epi data with the wastewater data to make sense of it. But what I think the gist of the main outcome will be that our testing has improved by about 8 to 10 times within a few months, from the early pandemic to the mid-pandemic. So also explains the sudden peak. You see a lot of cases suddenly, and a lot of it is better diagnosis. Yeah.
Yeah. So I think. I think what I've shared yesterday in my presentation is that we are used in our surveillance data to look at case data, and I think people that are working with these data and collecting these data understand the limitations, but in general, the general public and the politicians, they have been looking at these data as a reflection of the true circulation of the virus. And I think that's also because we didn't have anything better to show. But I do feel that looking or complementing these type of data with wastewater data, which are more objective coverage of the total population, and it's a bit of a population average rather than and what we're used to adding up case by case. But I do feel that that is one of a very strong value of an use case of wastewater surveillance. We have a general comment, which is also an interesting one. It's about the outlook towards the future. If we think about SARS-CoV-2 and other wastewater surveillance programs, and we now have the Polio Lab Network, which is sort of global. It is focused, of course, on the areas where the virus is endemic still, and countries where there is still risk of resurfacing. China has an enterprise surveillance system. As we say, SARS-CoV-2 is emphasizing justification of a global wastewater surveillance, not only to have such an early warning system in individual countries, but also to have let's say, a global early warning system of new infectious diseases that are emerging and showing up in a certain population's wastewater. Because I think in any infectious disease outbreak, the sooner you can try to intervene, the better you are. Your chances are to limit a pandemic. And of course, it really depends on also on the disease agents, as we see in the difference between SARS-1 and SARS-2. But still, it would be nice if we could come up with a global wastewater surveillance network. But then the question is where this system would sit, and that's the question coming from our audience. Do we have ideas about that?
I like the idea of the global, and I like the idea of to be screening for more generic, the genus rather than specific, and moving forward, whether it's influenza or flaviviruses or coronaviruses, more broad-based to be able to detect something emerging. Do you think that WHO will be interested? I think they should.
Well, I think WHO is the collection of all the member countries, which is again all of us. So I think if we as countries are interested, WHO it will surely be interested, and I think they have the strength to mobilize and to bring this idea further, and to maybe also secure global funding for it from the different member states. Because I think if we really want to have a global surveillance system, yeah, then it would mean that we all need to contribute. We collect our local wastewater information, and we do that in all the countries, and we share all the information that is out there. And I think you're right that there's a wealth of information in wastewater. So maybe we should call it information water or something. So it's not waste anymore. We already said it is a resource, but it's also an information source from what is happening in our society, and maybe one that is where we can very efficiently mine the information from, because we can take one sample and analyze a whole population. And with the new developments in analytics, like the microbial sequencing data that we're now using to track virus SARS-CoV-2 variants, we can also think of that more broadly and look at the total human virome and animal virome that is present in wastewater, and analyze what is happening with virus circulation in our human population, in animal populations, and see the trends that we see if we look at all the sequence data. It will be a huge amount of information, and it will also not be easy to already immediately make use and mine that information into something that can immediately turn into action. But I think we are really moving in that direction to mine this great opportunity.
You know, I'm just thinking that one of the best network in sort of driven by WHO is the influenza surveillance system, to the genetics of the virus, so that it could produce vaccine for the year, and the surveillance of the virus for influenza. So if this is possible with Sewell, wouldn't that complement that surveillance system? If Sewell can pick up influenza, whether it's influenza A, B, or would that be?
Yeah, I think yeah, go ahead.
Yeah, I agree.
Sorry, would that be one of the first? Because it's a very important to the WHO. Influenza genetics is very important, or the genotype, serotype.
Yeah.
So should it be something that we could start with that, since it's very important for the world?
Yeah. So influenza is the virus that kept epidemiologists up at night before 2019, right? And now we have a whole generation trained to be afraid of coronavirus as the next pathogen. And then there's pathogen X, like Professor Thompson was talking about. And we know the hotspots of viral emergence. And these are well documented. They're areas of high population density, as well as high human-animal conflict or interaction. And so those would be important hubs on this wheel, or spokes. And another interesting place would be the travel, the places with the highest travel global interchange. As any pathogen that arises is going to leverage our air networks. And the influenza surveillance is, as globalization increases, air travel increases, they're getting less effective at forecasting, because there's, 20 years ago, with limited travel across the Pacific Ocean, air travel across the Pacific Ocean, influenza would travel systematically from east to west every year. And now it's beginning to just go. And wherever it arises, it'll just go because of the interconnectedness of the globe. And so it raises the importance of infectious disease surveillance, such as wastewater. And I think of genome sequencing and wastewater to work in conjunction, where you can do amplicon sequencing from wastewater, but then also from clinical. If you see something in the clinical, you can point the wastewater PCR to look for it as well. And so I think it'd be fantastic to pursue that.
Okay, I think I'm looking to our hosts. I think we have come to the end of this panel session.
So we
Yeah.
have a project now, is it?
Yes, teaching.
A
I
project
think
and a
is-
mission, yes.
there's a mission for all of us. Somebody has to bring up this global wastewater surveillance system to WHO. All right, somebody got to do it. That will beneficial for the whole world, and that is the purpose of this conference, so that we get people together to make a difference. All right. Thank you very much for Professor Medema for chairing this session. I have a final request. Can all of us, the speakers, turn on your camera so that I can do a final snapshot of everyone who are here? So Celine, Layo, Rohim. Okay, 1, 2, 3. Adana, just give me 1 more second. Okay, 1, 2, 3. Okay. All right. Thank you very much. Finally, we come to the end of this e-workshop. I hope that you have found these 2 days to be fruitful and enjoyable. I'd like to thank the chair of the dialogue sessions, all the panelists, and all of you for your participation. We will upload the video recordings for today's sessions and also provide the emails of all the panelists as soon as possible on NARI website. Once again, thank you very much. Have a nice day or good night. All right. Thanks. Bye.
Thank you for hosting
Thank you.
this.
Bye.
Thank you very much.
Bye.
Most
Thank you.
welcome.
Thank you.
Bye.
Bye.
Thank you.